finally we will finish this problem from 4.5. Lots of information here, and we're all set up here to make a really awesome sketch now, but there's a lot to keep track of. So as we did in 4.3, you want to work left to right generally, I think is a good strategy, but it's sort of hard to actually work strictly from left to right, and you may want to actually start with the first point on the left and then kind of work backwards and later. So I'm just going to start at -3 and see what's going on here. Well, got that point there. The function is decreasing. Something happens at x equals -2. To see what's going on there, I got a vertical asymptote, but what's going on? Look at the limit from the left, -2. From the left is -infinity. Use the color here. So I'm going to put a little star there. I'm using that to make this next part. So as I come in from the left, I need decreasing, concave down, and as the function goes to -2 from the left, it goes to -infinity. So the simplest way to do that is to go like this. Double check. Decreasing, concave down, limit as x goes to -2 from the left is -infinity. All jives there. Now maybe I want to go back and see what was going on before x equals -3. So as continue to decrease is continue to be concave down. And then the limit as x goes to -infinity is y is equal to 2. So I'll put a star next to that. So connecting that and putting that all together would be something like this. That all jives. Now I'm going to pick up to the right of x equals -2. So this next limit, x goes to -2 from the right, y goes to infinity. So I'm going to have something like that. And then the function is decreasing, concave up, comes into a local minimum at x equals 0. So the way to do that simply is that way. Now, it's still concave up, it's increasing at x equals 2 from the left, y goes to infinity. Putting that all together, have the following, and so I can just draw that. I do need to think about symmetry here in that I want the function to look exactly the same on the left and the right except reflected. So, you know, I want to make sure that I'm sort of doing that now. Next thing, as x goes to 2 from the right, y goes to -infinity, the function is concave down and increasing and goes into the point 3, 0, which I'm going to redraw that just to make it more obvious what the concavity is. Try again. There we go. And then the limit as x goes to infinity, y goes to 2. Continues to be concave down and it continues to be increasing. Simplest way to do that, just like that. So now I'm going to use my symmetry as a check. I have that beautiful even symmetry, so that also kind of gives me some reassurance that I did this right. And that's it. So I will review this in the beginning of class on Wednesday as well.